Namaskaram. Welcome to the course Basics of Electronics. In this video, we will be looking into linear voltage regulators in electronic industry. This video is divided into 5 important parts. First one is what are regulators and why they are needed in electronics. Second one is about 7.8 and 7.9 series regulators. Third one is other voltage regulators in ESDM industry. Fourth one is advantages and disadvantages of linear voltage regulators. Last but not the least, fifth one is applications of voltage regulators in electronic industry. So let's begin. What are regulators and why they are needed in electronic industry? Regulators are the solid-state electronic devices which are used in most of the electronic circuits. In fact, every electronic gadgets around us will be having at least one regulator. They are responsible for keeping the output voltage constant irrespective of the change in input voltage. That's why they are so-called regulators. These regulators are used in electronic devices to ensure the efficiency of the device, making sure that output voltage of the circuit or a power supply should be constant irrespective of the change in AC input voltage. Example, if we consider any power supply in electronic equipment, we can see that there is a change in AC input voltage. Because of that, they convert that AC voltage into a pulsating DC by using a rectifier. And then we will add a filter circuit which is so called a capacitor filter circuit. After that capacitor filter circuit, the DC voltage is a pure constant voltage. But there is a change in levels of DC voltage because of change in the AC input voltage. That's why we add a small 3-pin regulator IC or maybe a 5-pin regulator IC to maintain the output voltage of the power supply, which is like plus 5 volt DC or plus 12 volt DC, irrespective of the change in AC input voltage. This is how the regulators are used and they are needed in electronic industry. About 7.8 and 7.9 series regulators in electronic industry. There are plenty of regulators and ICs available in electronic industry no matter what level of voltage and current rating you are looking for. But the 7.8 series and 7.9 series regulators are more popular in DIY segment and even in industrial segment no matter what is the case of revolution in integrated circuits. 7.8 series regulators are nothing but a positive voltage regulator and 7.9 series regulators are the negative voltage regulator. The 2-digit number added after 7.8 number or maybe a 7.9 number indicates the output voltage of these ICs. For example, 7805 is the positive 5 voltage regulator and 7905 is the negative 5 voltage regulator. If you study the data sheet of these regulators, you will identify how these particular regulators are designed and you can use them for your requirement. In fact, you can even identify their thermal behavior or the quiescent current behavior and most of the vital information with respect to manufacturing of these regulators and requirement of using these regulators in your circuit. Here are the few points which I collected for 7805 regulator from the data sheet for your understanding. First one is 7805 is the positive 5 voltage regulator with a maximum of 1 ampere of current carrying capacity. Second one is TO220 or SOT23 or D-square pack, 3 variety of packages available for this 7805 regulator, which means you can use this particular IC as a through-hole component or as a SMD component. Third one is the minimum and maximum input voltage for 7805 regulator is ranging from 7 volt DC to 35 volt DC. At the same time, absolute maximum voltage condition will be 45 volt and it is restricted. Fourth one is this 7805 regulator requires aluminum heatsink at the backside because when you are using this particular regulator for 1 ampere of a current draw, it will get red hotted up to 125 degrees Celsius. And as always, typical application circuit and typical performance graph, all that detail is given inside the data sheet for your understanding. As per the requirement, you can understand the graph and understand the typical application circuit and use them for your application. Other voltage regulators in ESDM industry. As I already mentioned, there are plenty of voltage regulators in electronic industry, and as an evolution of silicon deposition or silicon manufacturing, there are so many options and categories are invented in linear voltage regulator section. Here are some few examples for your understanding. First one is LD1117. This is a general purpose linear voltage regulator which is having a range of output voltage from 1.8 volt to 5 volt. This is also called as a LDO, which is nothing but a low dropout voltage regulator, which means it only drops 1 volt of output voltage with respect to the input voltage. If you apply a 6 volt at the input side, it can provide you 5 volt of DC voltage if it is a LD1117 5 volt linear voltage regulator. Second one is LM317. This is a variable voltage regulator based on the output to ground terminal voltage divider circuit, which will create a reference voltage for the adjusting pin of this particular regulator. You can adjust the output voltage. The output current maximum limit is 1 ampere with a variable voltage ranging from 1.8 volt to 32 volt. Third one is LM347. This is a positive voltage regulator with a 1.5 ampere of a current rating at its maximum. This is also similar to LM317 but has a couple of different features compared to LM317. Fourth one is Zener diodes, which are used for a voltage regulator in most of the cases. These are very straightforward, very compact and very useful in case of a compact electronic devices. But they have some downside as compared to voltage regulators ICs like 7805 or LD1117 or LM series regulators. But they are very cost effective and very suitable for a small scale application. Advantages and disadvantages of linear voltage regulators. Let's talk about the couple of advantages to understand these linear voltage regulators much better way. First one is these linear voltage regulator circuits are very easy to make and easy to use them. The only thing that you have to calculate is all about input capacitance and output capacitance. Other than that, there is no other electronic component has to be attached along with these linear voltage regulators. That's why it is quite easy to use them at any point of time with a minimal circuitry around them. Second advantage is low output ripple voltage. If you consider a 7805 regulator, it has a maximum of 5% of output ripple voltage, which means the variation of output voltage with respect to variation in input voltage or thermal condition. Third one is fast response to the variable load output requirement. When you are connecting a resistive load or any kind of an inductive load to these linear voltage regulators, as the requirement of a current flowing through the linear voltage regulator is varies, these regulators respond very fast. As per the requirement of a load, they will quickly adapt to the requirement of the circuitry. Fourth one is no noise and no electromagnetic interference. As there is no inductor or inductive load or inductive components in the entire circuit, there is no necessary to understand about the electromagnetic interference or there is no noise because of any switching elements. That's why they are very simple, very straightforward. Fifth one is very cost effective for low budget projects. When you are doing a DIY project or in case of an industrial project where budget is the concern, then these particular regulators are the cost effective solution for that. That's why they are very popular in electronic industry. Now let's talk about the disadvantages of linear voltage regulator. First one is overall efficiency is very low compared to switching voltage regulators. As we know that switching voltage regulators are more efficient and more advanced. That's why output voltage to input voltage efficiency is very low with respect to linear voltage regulators. Second disadvantage is these linear voltage regulators are only suitable for step down operation, which means output voltage is always lesser than input voltage. You have to provide the higher input voltage to get the output regulated voltage, which is lesser than input voltage. There is no possibility that we can create a boost converter or buck boost operation in this particular linear voltage category. Third one is it requires a heat sink and a thermal analysis with respect to the design and development of PCBs. Because as they get heat while they are in working condition, it is necessary for us to take care of the heat dissipation with respect to the product development activity. Fourth one is linear voltage regulator ICs are not suitable for compact design. If you are considering an example of smartwatch or mobile phone or earphones, then it is not possible to use the linear voltage regulators as they are very big compared to switching mode power supplies. Fifth one is linear voltage regulators are having a more conversional losses when they are converting a non-regulated DC voltage into a regulated DC voltage as compared to a switching voltage regulator. As I already mentioned, efficiency is low with respect to linear voltage regulator because of conversional losses. Now it is time to talk about the applications of voltage regulators. First one is voltage regulators are used in every electronic circuit. Be it a linear voltage regulator or maybe a switching voltage regulators, we can see that every electronic gadget requires a voltage regulation. That's why voltage regulators are widely used in every electronic components. Second one is DIY projects and their power supply unit. If you consider any do-it-yourself projects on the internet or in the colleges, you can see that there must be one power supply, and those power supply can be built by using a linear voltage regulator or maybe a switching voltage regulators. Third one is product prototyping and development PCBs. When we are doing a prototyping or the POC of any idea for the mass production, we always start with the basic components available around us. On that case, we can use the linear voltage regulators at the first stage of the development activity and then later switch to a PMS ICs, which is nothing but a power management ICs, or maybe a switching mode power supplies in later case. Fourth one is power electronics and power conversion circuit. No matter what level of power electronics or maybe power conversion circuit you consider, there must be a DC switching circuit for that. And that particular DC switching circuit or a microcontroller circuit requires a regulated voltage. And for that, you need to have at least one linear voltage regulator or auxiliary power supply. That's why voltage regulators are essential in every electronic circuits. This is all you need to know about the voltage regulators in electronic industry. I hope you enjoyed and understood the concepts discussed in this video. See you again in the next tutorial. Until then, happy learning. Namaskaram.